This unit, students extend their understanding of two- and three-dimensional figures. They use what they know about area and surface area to solve problems that involve higher-order thinking. For example, they see how they can decompose figures to find unknown lengths. They use variables to represent these unknowns, and, when needed, they express one unknown length in terms of another. As they write equations to represent areas of complex figures and then solve for the unknown, they are connecting what they've learned about algebra to geometric measurement. In 6th grade, students relied on nets to find the surface area of prisms. Now they begin to move away from concrete models as they solve surface area problems by reasoning about the faces of prisms. To find the surface area of composite figures, students can use the familiar strategy of decomposition. When using this strategy, though, they find that they need to account for the areas where the smaller figures overlap, as these sections do not appear on the surface of the composite figure. Students also extend what they know about volume in this unit. In earlier grades, they developed the formula volume equals the area of the base times the height to find the volume of rectangular prisms. Now, they look at triangular prisms formed by slicing a rectangular prism in half. Each triangular prism has half the volume of the rectangular prism. This observation helps students confirm that the formula V equals B times H gives the correct volume for the triangular prisms. And in fact, they see that the same volume formula applies to all prisms. To find the volume of composite figures, students once again use decomposition. They can decompose a composite figure into smaller figures and then add the individual volumes. Or, when the composite figure is a prism, they can first decompose the base of the prism to find its area. Then, once they know the area of the base, they can apply the volume formula. In this unit, students also think about what happens when a plane slices a three-dimensional figure to form a two-dimensional figure called a plane section. They learned that a three-dimensional figure can be sliced parallel, perpendicular, or at a slant to its base. And they find that each of these slices may result in a plane section with a different shape. They also see that the shape of a plane section can depend on the number of faces or surfaces that the plane slices. In earlier grades, students classified angles based on their measures. Now they consider relationships between pairs of angles, such as supplementary angles. They also investigate complementary angles, and angles formed by a pair of intersecting lines, like vertical angles. Students apply these angle-pair relationships to write and solve equations to find unknown angle measures. Once again, they connect geometric and algebraic reasoning to solve problems. In preparation for their work with congruence and similarity in later grades, students explore the number of different figures they can draw to meet given conditions. For example, they try to draw triangles with sets of 3 given side lengths. As they experiment with different sets of side lengths, students start to see a pattern. They can form a triangle only if the sum of the lengths of the 2 shorter sides is greater than the length of the longest side. Students also investigate other sets of conditions involving quadrilaterals and triangles. They attempt to draw figures by using rulers and protractors or by using technology, and they can determine whether the conditions result in more than one figure, a unique figure, or no figure. Throughout this unit, it's important to focus on students' conceptual understanding of 2- and 3-dimensional figures to help them build a strong foundation for geometric reasoning in later grades.